All right, in this video we're going to learn how to count, but in a very complicated fashion. So I want you to recall something. Recall when A and B are independent events, then the size of A and B equals the size of A times the size of B. As an example, suppose a room has 3 ways in and 2 ways out. How many ways are there to go through the room? So it might not be a bad idea, at least for this example, to draw a picture. Let me see. Let's suppose we have it go like this, and I'll leave little spaces for where the ins are. I'll leave little spaces for the outs. So what I have here is a way in here, a way in here, and a way in here, and then I have a way out here and a way out here. So let's number these ways in and out. I'm going to call this 1, 2, and 3, and so as not to confuse us, I'm going to use different things for the out. So we're going in and out. How many ways to do it? So if you look, you could go in one and then you'd have any of 2 choices to go out. And as you could see that for each of the 3 possibilities for going in, there's 2 ways out. That gives us a total of 6 ways. And you can even see it easier by taking a look at this a diagram where our first choice was the way in. So I could say that this was 1, 2, or 3. And then from each of those, you could make the choice of doing A or B. And so you can see if I label each of these, then if I go along this first arm, I'm going to have 1A, that's one particular outcome. Then 1B, 2A, 2B, 3A, and 3B. 6 outcomes. So if we look at the number of in and out, we get the number of ways in times the number of ways out. One thing you should ask yourself is, how do we know it's independent? Well, because once you choose a way in, you are free to choose any of the 2 outs, because I didn't specify in the problem that there was any restriction on doing so. So these are, in fact, independent. A businesswoman can create an outfit using a blouse, a skirt, or pants, and then shoes or boots. Footwear, I should probably just call it footwear. So let's call this, well, we can call it blouse. I'll just leave it this way. So I'll call this be blouse, skirt. This is going to be tough. Then maybe SH for shoes. Anyways, she has 10 blouses, 4 skirts, 6 pairs of shoes. How many outfits can she create? Now this one is a little bit dicey. I'm going to say these are independent events because no matter what blouse you pick, you're free to choose whatever skirt you pick. Obviously, this is not taking into account any ideas of matching clothes or anything like that. So in the context of the problem, you're freely able to mix and match any items with any other items, and nobody is going to talk about you. So with that being said, how many outfits can she create? She can create an outfit based on blouses, and she has 10 of them. Skirts, she has 4 of those. And shoes, she has 6 pairs. So all you do is multiply them together and you get a total of 240 outfits. The importance of this is that with, let's see, 10, 14, 20 different items at her disposal, she's able to create enough outfits for practically the entire year. If you throw a blazer on top of it, the combinations, or I'm sorry, the possibilities just get even bigger by however many of those she has. How many ways can you line up 3 people in a line? So for purposes of this problem, I'm going to call the people A, B, and C. So when you look, if we're going to line them up, we must have a first position, a second position, and a third position. For the first position, we're free to pick any of A, B, or C. So we actually have 3 choices for the first person. Now, once that person is set, there are 2 people left over. So for the second spot, we can choose any of the 2 people that would be left for that position. And then by the time you get to the third spot, well, that last person just has to take it. And you get a total of 3 times 2 times 1, which is 6. In fact, we did a notation for this. This was called 3 factorial. How many ways can you arrange 10 people in a line? And it's no different from the previous problem. If you look, for our first position, we have any of 10 people that we can select. Then for the next position, the second place, after we place the first position, we now have 9 people to choose for the second spot. And then the third spot, we have 8 people to choose from. Well, you can see where this is going. I'll just do dot, dot, dot until you get down to the second position. And then finally, I shouldn't call it the second position. I should call it the 9th position. And then the 10th position. By the time you get to the 9th position, there's only 2 people left. And of course, when you get to the 10th, there's only 1 person left. And as you might have guessed, this is equal to 10 factorial, which is equal to 3,628,800. There are n factorial ways to arrange n objects in a line. Chuck has 5 trophies. How many ways can he arrange them on his fireplace mantle? And as you might have guessed, hopefully, it's simply 5 factorial, which equals 120 ways. Now, let me complicate Chuck's situation a little bit. Suppose Chuck has 2 first-place trophies and 3 second-place trophies. Now, he wants to line up his trophies, but he wants to make sure the first place ones come first. So Chuck wants to line up the trophies, but the first place trophies must come first. So the way he has it, I think I can make a picture like this. Let's look at, this will be the first place ones. So this will be first place trophies. And then he's got his second place trophies. All right, for the first place trophies, he's got 2 of them. That means inside of this, he has a first and second spot. So first and second. And over here, he has 3 second place trophies. So he has a first, second, and third spot. So let's look at the first place trophies. He has 2 of them that he can select to be at the very beginning, and then after he places that one, there's only 1 left, so he's taking care of the first place trophies. I'll put it out here and indicate more multiplication. Now for the second place trophies, he has 3 of them. So to display which one comes first, he has 3 to choose from. And then after he places that one down, he has 2 to choose from, and then 1 to choose from. So you can see that this equals 2 factorial times 3 factorial. And the total answer to this is equal to 12. Here for this next example, we have a group of 10 reporters want to interview a celebrity. The celebrity will only grant 3 interviews And not only that, they're very specific on the interviews. The 3 interviews will look like this. One 15-minute interview, one 10-minute interview, and one 5-minute interview. How many ways can the 3 reporters be selected? So you may not see it directly, but there is an ordering here. If you take a look, the first place is the 15-minute interview, if you will. Second place reporter will only get 10 minutes. And then the third place reporter will only get 5 minutes. Now for this, the 15-minute interview can be given to any one of the 10 reporters, so let me put that there. Now the 10-minute interview will be given to any of the 9 remaining reporters. So we'd pick one of the 9. I have 9 choices for that. And then after those 2 reporters are settled, then the last reporter can be chosen from a group of 8 people. So you get a total of 720 here. I'm going to introduce in here a notation. It looks like this. In the last problem, we did something where we had 10 people to choose from, and we selected 3 of them. There's a notation here. I got it written here. It's 10P3, and the 10 and 3 are slightly lower than the P. But this means to take the number of permutations of 3 things taken from a group of 10. So if you look at it, let me write the formula down that we had here. We had, in this last problem, we had 10 times 9 times 8. Now I'm going to do a trick. I'm going to multiply the top and bottom by the same amount like this. Now if your eyes glaze over at such experiments, you of course can ignore this and just fast forward to the next part of the tape. But the reason I'm writing it like that is because the top now becomes 10 factorial and the bottom becomes 7 factorial. And I can actually do one more cute little thing, and it looks like this. The top, I still want it to be 10 factorial, but the denominator, I want, instead of 7, I like to write it as 10 minus 3. Now let me put the symbol here. This way you can see how it works. I see my 10s. Wherever I see my 10s, I see them there, and I see my 3. So this is the definition of that. Let me write it using letters N and R instead of the numbers that I had, so that I can give you a formula. So the formula for this thing, NPR, is N factorial divided by N minus R factorial. Your calculator has the ability to do it. So let me redo this last problem. What was it, 10P3? 10P3 using your calculator. Now in this calculator, the way you write it is you put the 10 first like this. Then you go to Math. See, go to PRB up there so you can arrow your way over to it. And I want to choose number 2, NPR, and then I put a 3. And then just hit enter. And you get your 720. Now for the TI-30X calculators, it's really easy to find yours. You enter it in the same way, so I'll put a 10, but then you'll click your PRB button, and you'll just select the first item in the list, and then you'll follow that with a 3 and then equals, and you'll get 720. Most just straight up scientific calculators will have NPR on the keyboard itself, so make sure that you can find that. "20 people are vying for 3 positions: president, vice president, and secretary. How many ways can we choose 3 people?" Well, the solution here, since we have president, we have a first position, vice president is second position, and secretary is third position. The order that we choose these things matters. So what we're going to have here is we're going to have, let's call it the president, VP, and then secretary. So for the president, conceivably any of 20 people can be chosen. For the VP, conceivably any of the following 19 people can be chosen. And then finally, after 2 people are placed, that leaves 18 people for the secretary. However, you can also do the same thing by simply doing 20 P3. You'll see we get the exact same answers. Well, I'm getting ahead of myself. Let me quit first. You have to put your number down first. I got to put my 20 first. Then I go to Math, PRB, choose number 2, and then hit Enter. Oh, put a number 2. I'm sorry. I am getting way ahead of myself here. I meant to put a 3 there. Now I can hit Enter. And I get the 6,840. I want you to know some places will do this PN, R, and that's the same as our notion of NPR. So you'll, depending on what book you look at, they may have certain things, notation that's slightly different than ours. But keep this in mind. Whatever you do, the order is important. Notice in every single one of the problems that I did today, who came at first, second, third, or whatever was important. So when you're talking about order, you need to talk about the letter P. The letter P does stand for permutation. So in reality, we can always say NPR is the number of permutations of R objects taken from a collection of N objects. But unfortunately, that doesn't really mean a lot to anybody. It's probably best to do problems like this and to set down and make sure that you have an order implicit in the problem. A celebrity will only grant 3 interviews, but there are 10 reporters ready. How many ways can you select the 3 reporters? So how do you choose the three, or how many ways are there to choose these three? Notice it's different now. I did not say that one person would be given a 15-minute interview and then the next person a 10-minute interview. In fact, nowhere in this problem is order indicated. So order is not indicated at all. It's not even implicit in no way, shape, or form. So we're not talking about permutations here. We're talking about something else. Let's think about how we would select them. If we were going to select these people, the way we've been doing this before is I've got a first selection, I've got a second selection, and I've got a third selection. This is what we were doing before. So we would have 10 people for the first that we can choose for the first interview, 9 people for the second interview, and then 8 people for the third interview. This is a little different. We're just grabbing 3 reporters at random. And it doesn't matter which one comes first, second, or third. So how do I unorder this? Well, ordering means to multiply in this fashion. And the number of ways of arranging these 3 people is given by 3 factorial. So 3 factorial lists the number of ways to arrange them. So if I want to unarrange or ignore the order, so to ignore order, divide by 3 factorial. So we get this. So I'm going to get all that, but it's going to be divided by 3 factorial. So what I'm really getting is 10 times 9 times 8 divided by 3 factorial. So in this case, we have 720 divided by 6. Now we only have 120 ways of choosing the 3 people. So the way to unorder them is to divide by 3 factorial. Now I'm going to do another little trick like I did before. I'm going to take this answer and I'm going to multiply the top by all this stuff again. And the bottom, I'm going to multiply by the same amount. And we end up on the top with a 10 factorial. And in the denominator, I get 3 factorial and 7 factorial. The notation I want you to be comfortable with here is NCR. These are called combinations, and combinations do not care about the order. So your calculator is able to do this. In fact, I put an NCR, but in this case, the N is a 10 and the R is a 7. So we can take our calculator. Actually, I'm sorry, we're only choosing 3 people. So, and you know what? If you put a 7 there instead, you'll actually get the same answer. But I won't. I digress about that. Let's see how you get this number. You take your calculator, turn it on. You can always use the formula. That's always possible. But really in the exact same space that you were before, hit your 10, go to math, and then go to PRB and look at number 3. And then put a 3 after that, and then hit enter. And there's the 120 like you got before. So in effect, the formula for NCR equals n factorial divided by, I don't know which way I want to put it. I think I'll put r factorial here and n minus r factorial here. So this is the formula, and that C stands for combinations. Combinations do not consider order. In the Ohio lottery, I think it's called the Mega Millions, you pick 6 numbers from a collection of 47 numbers. And then on lottery night, they pick 6 numbers from 47, just like you did. You win if your 6 numbers match the ones drawn on lottery night. And there's one very specific thing that's thrown in here. If your 6 numbers match the ones drawn, so let me write this. If your 6 numbers match the ones drawn in any order, that's part of the deal. If your numbers match the 6 that are drawn in any order, you win. So how many ways, well, let's put it this way. How many different 6 number combinations can be selected? This way. So how many can you get out of 47? Well, since the order doesn't matter, our solution is 47C6. So let your calculator handle the effort here and put your 47 first. Math, PRB. This time I want number 3. I want combinations, 6, and I hit enter. So I get 10,737,573. If you buy one lottery ticket, the probability of winning is you have one ticket that you purchased out of the total possible number of tickets. If you want a better idea perhaps of what your chances are, if I convert this to a decimal, I have 7 zeros, and then I finally get to a non-zero number. That's the probability that you win while purchasing one ticket. How many 5-card hands are there in a deck of 52 cards? So once again, order is not indicated here. When you receive your cards, if you're playing poker and they give you 5 cards, the order doesn't matter to you. In fact, you're probably going to rearrange them in the way that's most enjoyable to yourself after you get them anyways. So order is not important. That means we have 52 items to choose from. This is combinations, and we're choosing 5 of them. So 2598960. Here are a couple of exercises to get you comfortable with the difference between permutations and combinations. If you look at number 11, the child is simply picking 3 candies all at one time, so they're not picking them 1, 2, 3. So for this one, you have 24C3, and the next one, see what's happening now, he's picking them one at a time. That means when he picks, he has to pick a first one if he's picking one at a time. So immediately an order is assumed. Here you'll do 24P3. And you can check my numbers on your own, but I believe this is 2024. And this one here is 12,144. Notice that the P will always have a larger number than the C. Here's the same style of problems as I just gave you. In number 24, we have 14 flavors, and the Supreme Bowl is 4 different flavors. So they're just throwing 4 flavors in a bowl. So from there, since the order doesn't matter, we'll use 14C4. So you should see 1001 when you're done with that. The next one, an ice cream parlor offers 14 flavors, but this time the Supreme Cone is an ice cream cone with 4 different scoops of ice cream stacked on it. How many different Supreme Cones are you? And notice what it says is assume the order doesn't matter, so they kind of gave it away. So there, it's going to be the same answer. I'm going to get 14C4. Finally, for the last one, now the Supreme Cone is an ice cream with 4 different scoops of ice stacked up on it. But this is for those people that would walk in and they actually would care what is coming at top and bottom, and the order would matter to them. So in this last part, notice how order is implicit in the problem, and it becomes a 14P4. And that equals 24,024.